Okay, hey, this is Chris again. We're back with Substance Painter here, and this is exactly where we left off. I basically just paused one and started the next, made a nice break in video so that easier to follow. Um, we want to get these textures onto this model. The model, the UVs, are the exact same thing between the two. The mesh topology, the UVs topology, nothing that has to do with vertices whatsoever has changed. We've changed some images, and that's it. Um, and really, what we've done is we've combined a bunch of old images and then combined a bunch of procedural stuff and made some new ones. So now what we're going to do is we're going to go to File, Export Textures, and it's got two different sets here. We can export this at whatever scale we want. 2048 by 2048 is a good size to work at for the document. It's a bit on the large size for um, model like, a model like this. Creating an output folder. It always wants to put it in this particular export folder. I really dislike that aspect of it and wish it would default somewhere else. Let's see how big the 2048 ones are. It's going to export. It's going to complain that it's not able to generate a few of the maps. There were some warnings. You can see those in the log. None of that matters. Basically, nothing is opaque, so it didn't have an alpha to write. No big deal. And then it didn't have an emission map to write for the rock part, which is correct. The rock doesn't glow. I mean, it could, but it doesn't. Okay, so at 2048 by 2048, we're looking at 24 megs of space there. That is too much. So we are going to go down to 1024 on both of these and export again. Except for the really, really large stuff like a arc or whatever, pretty much everything should be fine at uh, 1024, and a few things like the really, really tiny stuff should be fine at 512, to be honest. So we went from 24 megs to 7 megs compressed in both cases because it's 4 times larger because of the um, being both wider and taller. It's cubed, squared. Blah. Um, all right, so now over here, I have, so this is back in the prep project here. This is more of a synth sort of thing, but blue, it's helpful if you know how to do this too, I think. So final game meshes, I was creating a folder, it's calling this what, AI buildings. Okay, so create folder, AI buildings, and then folder special forces guard post, and then show an explorer. And then I'm going to paste in these things. Actually, it's going to wind up going in a materials subfolder. It's going to want to make that. All right. So now we need to grab the models. Okay, first of all, it's importing those things. So now we need to grab the models just for the sake of cleanliness. I'm wanting to put these over in the same location. So we've got several different LODs here, and then the actual materials. Special Forces Ninja Hideout. Okay, yeah. And going to drag all of that in here. No longer need these textures, which were the original ones. They're in SVN anyway, if we needed them, or Google Drive, variety of other places. So is this our? That is not our. Darn it. So a lot of times Cinth makes a separate prefab prior to making the final real one. So should have been able to guess because it's not an asset bundle. All right, so we're going to delete this whole thing. That folder we're done with. This is no longer showing anything. All of these models share the exact same UV layout despite having different numbers of different levels of polygons in them. So just putting in the new textures will work. So we've got these ones here. So we had shader custom amped metal, my custom one. Take that away, go back to standard, take this away, go back to standard. The albedo we want to be white or close to white on both of them. So the meteor here, this is albedo transparency one, so this gets dragged right there. That's the new normal map for this. So we drag that. Drag that right there and hit fix now, so it actually becomes a normal map. This is the metallic and smoothness, which is pretty critical. This says pull from albedo alpha. Bad. It should be saying metallic alpha. Otherwise, it won't pull the smoothness correctly at all. That looks weird for reasons that are not clear to me. Meteor normal, blah, blah, blah. All right, well, come back to that. Video transparency, that's the emission. Okay. So, oh, there is an emission property turned on that. Maybe that's part of it. Oh, the normal map's at negative 0.011. That's why. Normal map should be at 1. There we go. Okay. Now that looks normal-ish. It's a little bit on the whited out side. Yeah, right. So we'll just down the smoothness a little bit. There's occasionally some tuning by hand that has to happen once you get into a new lighting environment. Which this lighting environment is a lot closer to what we'll actually see in the game. So you can see that in the shadows and in the light, it looks kind of like what you'd expect a rock to look like. So, all right, I'm reasonably happy with that. Okay, here. All right, so now we got this normal map here. Fix now. Normal map is at 1. Good. The emission thing, fine for now. Albedo here, fine for now. This should be the metallic thing. It is. Okay, fine for now. Now, this does not really look like this, does it? Getting there. Now, first of all, at this point, we can start cranking up the color emission a bit. Anything over 1 goes into the HDR range. You can grab right there. Oh, we're having specular highlights and reflection. That's what's going on with the rock. So we don't want that. We don't want reflections for sure. We also don't want specular highlights. So now we can turn the smoothness back up to where we expected it to be. And yeah. Maybe not. I'd rather have lighter specular highlights anyway than what we've got. So on this side, we can also come in and actually colorize these a bit, and then drag this up into the HDR range so we get better color, different way. We want this overglowing, but we don't want it to be so the bloom I will take care of later because the bloom is a little on the crazy side. One of the things is this is not pointed directly at the light right now. So let's try turning this. And so when you get this at a different angle to the light, you start seeing different amounts of shininess to the different parts of it, namely the metal parts there. So that's looking a lot more like that. Now that's really nice IBL lighting in Substance Painter versus we just have a single directional light going on right now in the in this Unity scene. So it's one of those things where you go, oh, this was so exciting and neat. But it's lit from basically all sides. And by the equivalent of like ambient lighting of different sources versus this is lit from only one side. And the dark side looks kind of neat and the light side has its own look to it and all that. And it still looks physical and whatnot, although it's not quite as good as what it was in Substance Painter, such as life. There are a few things we could do to clean it up, but I think the only people that would really notice or care are those of us watching it actually happen in real time. Because it's like, oh man, it looked so much better just a second ago, but you know, it still looks really good this way. I want to note that there are other ways in Unity to get something a lot closer to the Substance Painter look, namely by using the alloy shaders. And I have less experience with them, but I think the Lux shaders can also be used for that. Alloy shaders, excuse me, are not free. So we can't distribute those openly for anybody to use. And it would look a little weird if some of the stuff used it and some of it didn't. So using the Unity standard shader makes more sense to me. When it comes to Lux, that's something that has gotten out of date frequently. And so I'm not real excited about using that in the real near term. The normals look a little tame on this actually. So we can actually crank it up a little bit. Ah, that's crazy. That's not good there, but crank it up a little bit at least. Gives a little better look probably. Might be a little too much still, but one of those things that can be tweaked with. So at this point, do a save, Arkin, save all assets. The only things that we've changed are we've moved the folder that a few things are in, but not even a prefab. We've updated these two materials and we've made new textures, which are now being used. These things are at normal quality. They're being compressed as DXT5s. Actually, these ones are linear DXT normal maps. So 1.3 megs in VRAM for that, 1.3, 0.7, 0.7, 1.3, 1.3. So that 7 megs of PNGs that are on the desk, or, on my machine are probably pretty accurate in terms of this. If we wanted to go for higher fidelity, we would need to be using height maps and occlusion mapping, and Alloy has a special way of baking in specularity even when using the metallic roughness pipeline. It's using this thing from a white paper that Disney wrote. It's pretty cool. But we don't have the GPU budget for that in AI War 2. There's too much stuff drawn on the screen. And believe it or not, but what we're drawing here now with these two things is actually more efficient than what we were drawing before it looked this good, the one that we had before. Rendering this thing here is more expensive than rendering this thing. Welcome to modern graphics cards. Part of that is because of the shaders in particular are using more stuff. This is not the best example of one. This one's actually pretty efficient. But some of them are pulling in a cube map. And at any rate, yeah, thanks for watching. That was a quite long dive. I'll probably do another one that's just a, like, let's do a quicker, more reasonable one. So.